Alright, so we are going to start off with the product of powers property. Kind of a tongue twister. Product of powers property. So property in math, that's just like basically saying a rule. Product means what operation? Multiplying. And then the other P word up here is powers. So let's review what a power is. Let's say we have 7 to the 4th power. The entire thing is a power. Again, the entire thing, both numbers are is the power. The biggest number is called the base, and the little number is called the exponent. So the base and the exponent together make up the power. So what we're going to be doing is we're going to be multiplying different powers together. And there is a rule that goes along with that. So that's what product of powers means. Alright, this is basically what it says. Now I think it's a lot easier when your base is a variable. It's easier to see kind of what's going on. If we had a to the 4th power times a to the 3rd power. What does the exponent tell you? In a power, what does an exponent tell you, Daphne? How many times you're multiplying the number by itself? Very good. So for instance, a to the 4th power, that would be a times a times a times a. And a to the 3rd power would be a times a times a. So here I have 4 a's times, over there, 3 a's. So how many a's total do I have? 7 a's. So this would equal a to the 7th power. So what do you think we could say our rule is? The base stays the same and add the exponents. Good. So we really are not multiplying anything here. So even though this is the product of powers, we're not multiplying the exponents together. So what we are going to do, this is super important that the bases must be the same. Bases must be the same in order for this rule to work. So they are both a's. They both must be an a, or they both must be the same number in order for this rule to work. And once again, the rule is keep the base, add the exponents. So we are going to practice doing this sum, okay? So let's say we have the problem x to the 6th power times x to the 9th power. What would be our answer using this property? X to the 15th power. So you're keeping your x, you're doing 6 plus 9, so your answer x to the 15th power. This is not something that I would expect to see work shown. I'll say that again. I do not expect to see you show your work on doing this. I know that you can do 6 plus 9 in your head. I showed my work up here on the board because I wanted in the notes everyone to see where we were getting that 15 from. Okay? This works the same even if you have more than 2 powers, like the last couple of examples. For instance, if we have a to the 5th power times a to the 2nd power. Now, before we do this problem, let's talk about this power that's in the middle here, this a. I don't see an exponent. So when you do not see the exponent, Stephen, what is it? It's a 1. Okay, we have 1a, but they don't show the 1. So we have to remember, though, when we're adding these, we don't still say, oh, 5 plus 2, and there's nothing there, so I don't add anything. That is an invisible 1. as a 1 for the exponent. Because again, there is 1a there. So what we're really doing is 5 plus 1 plus 2, which gives us 8, a to the 8th power. Now be very careful when you're doing this and your base is a number. People sometimes get those mixed up because they want to multiply their numbers. For instance, 8 to the 2nd power times 8 to the 9th power. Some people want to do 8 times 8 is 64 to the 11th power, and that is not how you do these. Remember, the rule was keep the base, and the base is an 8. So keep the base and add the exponents. So it's 8 to the 11th power, not 64 to the 11th power. Okay? So don't multiply your bases. Keep your base. Now there is a time where you actually do multiply numbers together, and that is when you have coefficients. Who remembers what a coefficient is? Okay, let's review that real quick. So a coefficient, what does the prefix co mean? Together, okay? Like a co-worker, someone you work with. So a coefficient is a number that's working with a letter, okay? A number in front of a variable. A coefficient is a number that comes in front of a variable. An example, if I had 3x to the 4th power, the 3 would be my coefficient. It's the number that comes in front of a variable. Okay, that's the coefficient. So you can use this product of powers property when you have coefficients as well. And our rule for that, if you have coefficients, first we're going to multiply the coefficients. And then everything else is the same. So second, keep the base. Third, add your exponents. So multiply the coefficients, keep your base, add your exponents. We'll do a couple examples of that, and then we'll talk about the quotient of powers property. Multiply the coefficients, keep the base, add your exponents. So if you had the expression 3x to the 2nd power times 5x to the 5th power, what are the coefficients? The 3 and the 5 are my coefficients. So I'm going to multiply my 3 and my 5, and that gives me 15. I'm going to keep my base, which is x, and I'm going to add my exponents, which would give me 7. And there's your answer, 15x to the 7th power. All right, I'm going to give you one to do on your own, and then we'll move on. Let's say we have 2m to the 4th power times m to the 5th power times 7m. Try that one on your own. All right, Stephen, what'd you get? 14m to the 10th power. Who all got that? Oh, that's lots of people. So the 2 times the 7. I don't see a number in front of the m to the 5th power. That means technically there's a 1 there. So 2 times 1 times 7. That would give you the 14. M is your base. And adding your exponents, 4 plus 5 is 9. Don't forget there's an invisible 1 here. So 9 plus 1 would give you that 10. All right, any questions about the product of powers property? right, then let's move on. Let's move on to the quotient of powers property. What does quotient mean? All right, so quotient has to do with dividing. So dividing is the opposite of multiplying. So since dividing is the opposite of multiplying, and for multiplying we add the exponents, what do you think we do for quotient? You got it, okay? So you knew the rule before I even wrote the rule. So again, we're going to keep the base and subtract the exponents. We're going to start off with some examples that do not have any coefficients. These problems are going to be written to look like fractions, but we know in algebra that's how they look. Okay? When it's a division problem, it's going to look like a fraction. For instance, if I have x to the 5th power over x to the 2nd power, what this means is x to the 5 minus 2 power, so x to the 3rd power. Technically, that is in the numerator position, but we don't need to write it anymore as a fraction. What we're doing here is simplifying anyway, but we know anytime we have a base or just a number, if we wanted to write it as a fraction, we'd put it over 1. Okay? So technically, this is in the numerator. That will become important later. Technically in numerator position. So x over 3 over 1. But again, we don't want to write it like that because that is not simplified. So this works the same way even if your base is a number. So if we had 6 to the 12th power over 6 to the 8th power, what would your answer be here? Six to the 4th power. 12 minus 8 is 4. 6 to the 4th power. All right, we okay on that? And then we're going to start talking about if there's a coefficient in front. Questions? So far, so easy. Good, right? It's pretty easy. Adding, subtracting makes it pretty easy. All right, so again, let's talk about when there are coefficients involved. For instance, if we had the problem 4x to the 8th power over 10x to the 2nd power. So when we had coefficients for multiplying, we just multiplied the coefficients. But here, we don't really want to do 4 divided by 10 and get a decimal number. Okay? What we're going to do is we're going to look at our coefficients only, the 4 over 10, and we are going to simplify it like it's a fraction. Okay? So simplify, really what we're doing is reducing the coefficients like it is a fraction. So 4 over 10 simplifies to 2/5. 4 over 10 simplifies to 2/5. So we have this 2 over 5. And now we look at our bases, or our powers rather. Our powers are x to the 8th, x to this divided by x to the 2nd power. What would be our answer to our bases? X to the 6th power. And where does it go? Would it go up by the 2 or would it go out by the 5? What did I say in that last problem? The 2 because it's in the numerator. So very important that you're putting this power up here in the numerator by the 2. It does not go by the 5. Okay? So this would be your final answer right here. Okay? Let me go through our steps again. So looking at just the coefficients, we simplified that like it was a fraction. 4 over 10 is the same thing as 2 over 5. We're good with that, Addison? Okay. And then we're looking at our powers separately. So forget about your 4/10, think about this only. X to the 8th over x to the 2nd, that means x to the 8 minus 2, which is 8x to the 6th, and super important that we're putting that up there in the numerator only, okay? Sometimes color coding, it helps people see it better. We want to do the same steps even if our fraction is going to give us an improper fraction. For instance, if I had, whoops, I'm still writing in. If we had 12 n to the 5th over 8 n to the 2nd power, we can see that it's an improper fraction given to us. We want to leave it improper. Do not write mixed numbers. So no mixed numbers. Leave improper. No mixed numbers. So 12 over 8 would reduce to what? 3 over 2. They can both be divided by 4. So 3 over 2. And then it's going to be n to the what power? 3rd power. N to the 3rd power. Does that go by the 3 or the 2? The 3. Remember, it goes up in that numerator position. Alright, any questions about that one? We're almost done. Alright, in these last couple of problems that we're going to practice together, I'm going to combine the two properties together. We're going to be doing both properties in the same problem, okay? So if we had the problem 3m to the 5th power times m to the 2nd power over 6m to the 3rd power. We want to do a problem like this in 2 steps. We first want to simplify anything that's in our numerator and our denominator. So that's kind of following the order of operations. Alright, so again, we're doing the top first. So looking at your coefficients first, 3 times, what's here? 1. 3 times 1 is 3. Keep your base. Add your exponents. 5 plus 2 gives you 7. All of that goes over 6 m to the 3rd. So again, that was our first step, was doing just the numerator. Now we are going to do this as our second step. So we're going to simplify our fraction. 3 over 6 equals 1 over 2, a half. Good. And it's going to be m to the what power? 4. 7 minus 3 is 4. And that's going to go up top. Now technically that's your answer. However, we don't write a 1 as a coefficient. We just leave nothing there. So although I would accept this answer, really the best answer would be m to the 4th over 2. That would be the best answer. Questions about my steps there? Do you want to do one more example of this, or you got it?
I got it.
I believe you.